Hey y'all, welcome to my channel Land Before Time, with your host Littlefoot. If you didn't get that reference, you probably grew up in Dinosaur Train. Either way, welcome aboard. Today we're going to be covering a number of islands. Given an n by n 2D binary grid, which represents a map of 1's land, 0's water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all 4 edges of the grid are all surrounded by water. Before we begin, if you don't have a system that's giving you the results you desire, I highly recommend checking out my 5-step guide to your Leetcode enlightenment. The link will be in the description below. Now, let's jump into solving number of islands. The goal is to count the number of islands, so let's write that down. Whose islands, you may ask? Can't tell you that, because I got none, and the problem to tell me. Maybe Zuck's? Either way, let's move on to asking some clarifying questions from the interviewer, as we want to make sure we don't accidentally assume the Hawaiian Islands instead of the Japanese islands. Fun fact, Japan has 6,852 islands. Alright, enough of the silliness. Questions. What are the constraints of our inputs? And in this case, we're just going to go ahead and scroll down to the bottom, and we'll see constraints are right here. Typically, in an interview setting, the interviewer will copy-paste what the constraints are, so let's just go ahead and say Leetcode. The next question we want to ask is, what defines an island? And the problem has told us that an island is defined by adjacent lands horizontally or vertically right here. So let's go ahead and write that down. Other thing that we want to know is what represents land and water in this case, and also the problem tells us that. So let's also go ahead and write that down. 1 represents land, and 0 represents water. Now that we know what we're trying to solve, let's go ahead and take a look at the Leetcode examples. As we can see, this Leetcode example here is kind of big. Trying to walk through that in 30 minutes seems like a nightmare. So instead, let's come up with a few smaller examples instead of using Leetcode 1. Alright, so based off of the constraints here, we know that our smallest island is going to be 1, as in like this, and our output would be 1. And we could reverse this and our input could be 0, and then our output would also be 0 because 0 means water. Another couple examples that come to my mind that are really good walkthrough examples would be something like this, where we would have 1, 0, 0, 1. And here the output is going to be 2. And another one will be something like this. Alright, so now that we have some examples, let's go ahead and start brainstorming potential solutions that we see here. Given the problem that we have, my first thought is to use something like a BFS or a DFS, and considering we're not looking at shortest or longest paths, I would say go ahead and use whichever one you're comfortable with. In the case for me, I'm going to go ahead and solve this using BFS. Let's go ahead and take our first example over here. And to make this a little bit visually easy to see, let's go ahead and add in our indices. We know that we're going to start here for the first time. Let's go ahead and write that down. We realize that that is equal to 1. So we know since we are going to be using BFS, we will need a queue. And the things that we are going to be adding to the queue are going to be when the grid ij is equal to 1. Now what we're going to do is add 0, 0. So we know at 0, 0 we found a 1, and we're going to check all of its neighbors. There's only 2 neighbors here. Those are both 0, so we add nothing to the queue. One condition to note here is we want to make sure that they are in bounds. So gonna note down if in bounds, and the neighbors are 1. Then we're going to go ahead and add it to the queue. So since we're done with 0, 0, we remove it from the queue and we move on to 0, 1, which that's going to be 0. So we don't do anything. Same thing with 1, 0. We notice that this is 0. And now we're finally over here where we have 1, 1. Which that is equal to 1. So we're going to go ahead and add it to the queue over here. We only have 2 that are in the bounds, and both of these neighbors are not 1, so we don't add anything to the queue. And our count is going to be 2 at the very end of this. All right, so in this case, we have the 1 being exactly the island. However, we can have a case where the 1 is only a piece of the island. So let's go ahead and do a quick check with our example like this to ensure that our solution will work for both cases where the 1 is a piece of an island versus 1 is just an island. And here we're going to move a little faster since we get kind of the gist of what our solution is going to look like. All right. So here we can see 1. And we're going to go ahead and add this to the queue, which that's going to be 0, 0. We can see the 2 valid neighbors here, this one and this one. We're going to go ahead and add 0, 1, 1, 0 to the queue as well. And at this point, our count is going to also be 1. Now that we've added both of these here, we no longer need the 0, 0. So we're going to process 0, 1 over here, and we realize that the left neighbor of 0, 1, 0, 0 is 1, but we've already seen 1. So instead of reprocessing 1, let's just go ahead and mark it as visited, since we know that this is a character array. Now we're going to check to see if any neighbors that are in bounds are also 1, which there are no more neighbors, so we can go ahead and remove that from the queue. Then we process 1, 0, which that is a 1. And we can see there's no more 1s here, so we go ahead and remove that from the queue. And at the very end of this, we will have count is equal to 1. We're going to go ahead and move on to writing a little blueprint. These are basically notes that we can refer back to during our coding phase in case we forget something. All right, so what we're going to want to do is first we want to iterate through the entire grid. And if we see for position grid ij is equal to 1, then we know we want to go ahead and add it to the queue. After we've added it to the queue, we want to mark that it's visited. Then what we want to do is check to see if it's in the bounds and the neighbors are 1, and then we go ahead and add it back to the queue. And that looks pretty good to me. Or actually, one of the key things that we forgot is to actually update the count. So let's go ahead and do that. That looks pretty good to me. Let's go ahead and move on to the coding section. And there we have it, number of islands. With that said, happy Leetcoding. If you found this video helpful, give it a like, comment, share, and subscribe. And see you in the next one.